I'm Dr. Lalita from the Physics Department of Thandai Periyar Government Arts and Science College, Trichy. And I'm here to present a lecture on the classification of elementary particles and the standard model of particle physics. Elementary particles are particles having no internal structure, and standard model is purely a quantum mechanical model. And scientists use the standard model. They find convenient to use the standard model to express many quantum mechanical phenomena, and they are also able to explain the properties and the behavior of the particles of all kinds of matter. And the standard model consists of 12 particles, which is shown in the diagram. The outer disk, blue disk, shows 12 particles, 12 fermions interacting with 4 bosons, which are shown in the inner disk, orange color disk, and finally held together by Higgs boson. And all particles in nature belong to either of the two categories, fermions or bosons. Fermions are particles having half integral spins. They obey Pauli exclusion principle, which states that no two fermions occupy the same quantum state, and they follow Fermi-Dirac statistics, and they have antisymmetric wave function, which tells that when we swap two fermions, the wave function changes its sign, and examples for fermions are electrons, protons, neutrons, etc. Many particles come under all the 12 fermions of the standard model. And bosons, in contrary, they have integral spins. They do not obey Pauli exclusion principle. That means many bosons stay in the same quantum state. They enjoy the same quantum state, which leads to many quantum mechanical phenomena. This principle leads to many quantum mechanical phenomena like superconductivity, superfluidity, laser characteristics, Bose-Einstein condensation, etc., etc. And these bosons follow Bose-Einstein statistics, and examples for bosons include uh, photon, W and Z bosons, gluon, Higgs boson, etc. And the standard model is written in the language of quantum fields. And each particle is associated with a quantum field. All particles in nature are associated with quantum fields. When two particles interact, when we say that two particles are interacting with each other, which means that the quantum fields of the particles interact with each other, and simultaneously it also interacts with the field of Higgs boson, which gives mass to the particle, and hence which gives rise to the particle. And we understand the standard model in terms of particles only, and not of, for convenience we use the name particles, but actually in the fundamental level, basic level, only fields are interacting. And all fascinating objects in the universe that is around us is made of only three particles. So all of us are made of only three particles: electrons, up quark, and down quark. And proton, shown in the diagram, see, proton is made of two up quarks and one down quark, and neutron is made of one up quark and two down quarks. And this proton and neutron combine together to form a nucleus, and electron added to the nucleus, that is electrons orbiting around the nucleus, gives rise to an atom, and many atoms combine together to form molecules, and molecules combine in different fashions, in different proportions, gives rise to different kinds of matter, and hence the objects around us. All variety of objects like amorphous, crystalline, inanimate, animate, tiny, huge, light and heavy particles, and many more are formed due to the different combinations of matter in different proportions. And the fourth particle added in the standard model, first three particles in the standard model are electrons, quark and down quark, and the fourth particle added in the standard model is neutrino, And neutrino is not it's not interacting with the particles of matter. They don't interact with particles of matter. The particles of interaction are only electrons, up quark and down quark. And these neutrinos, they enter the atmosphere, the earth atmosphere, from cosmic ray showers, and from the sun, and from outside the cosmos they enter the earth atmosphere. And when and these neutrinos pass through us. Millions and millions of neutrinos are streaming through us and around us and through us, without affecting us. It is not affecting any of our any of us, and it is passing through unaffected. And so there are four particles in the standard model: the electron orbiting around the nucleus, the up quark and down quarks, which are responsible for the formation of neutron and proton. And fourth particle is the neutrino, which has no mass and no charge at all. These neutrinos are uncharged particles. And first it was thought that the neutrino has no mass, but later the Japan Observatory found that it has a negligible mass, even though it is traveling at a very high speed, that of light, but it is having a very, very negligible mass. It was discovered. And nature is not happy with the first generation of particles. First generation of particles are electrons. Electron neutrino. Instead of neutrino, we call it as electron neutrino. The quark and the down quark are the four particles in the four particles that belong to the first generation of particles. And nature added two more sets of particles, second and third generation of particles. And second generation of particles are heavier than the first generation of particles, and third generation is much more heavier than the first generation of particles. And hence they are shown in columns. To each first generation of particle, two sets of particles are added. To an electron, muon and tauan are added. For the electron neutrino, muon neutrino and tauan neutrino are added. For the down quark, strange and bottom quark are added. And for the up quark, charm quark and top quark are added. All these 12 particles or fermions, they have no internal structure. But the second and third generation of particles are not stable, they are weak. As soon as they are formed, they decay to first generation of particle. So on the right side, we have bosons, which we will see later. Now, standard model is incomplete without the description of bosons. We have described what are fermions, 12 fermions, and now we can see what are bosons. Standard model explains four bosons. For four types of interaction, we have four bosons, but standard model does not include gravity in its model. And the three interactions that are described in the standard model are strong interaction, weak interaction, and electromagnetic interaction. And the particles responsible for electromagnetic interaction is photon, and for strong interaction it is gluon. For the weak interaction it is W and Z bosons. And now finally there is a Higgs boson. This particle gives masses to all the fermions, binds all the particles. And let us see the bosons one by one. First is the photon. Photon is a massless and chargeless particle. Even though photon is a massless particle and chargeless particle, it interacts only with the charged particles like a electron, and no two photons interact with each other. Next is the gluon, which is responsible for strong interaction, and gluons interact between quarks. Quarks also carry charge, but that charge, quark carries a color charge. Electrons carry charge, electrical charge, whereas gluon is also charged particle which carry its charge is called as a special charge. It's given a special name called as color charge, and it is also massless and chargeless particle, but interacts with the color charged particles. And there is a major difference between electron and gluon. That is the field around the electron, electrical field, is radially outwards. It is pointing radially outwards, whereas whereas the gluon charge is confined inside the nucleus within a size of 10 to the power of minus 15 meters. It has very short range. Inside the nucleus only it acts, only between the quarks it acts, and hence it is the strongest force in the universe. We say that the nuclear force is the strongest force in the universe. Within a very short space of 10 to the power of minus 50, size of 10 to the power of minus 15 meters, all the protons or neutrons are held together because of the presence of gluons. And next comes the W and Z particles. The Z particle is an uncharged particle, and W has two charges, negatively charged and positively charged exist for W particles, and the W and Z particles are having masses greater than protons and neutrons. They are heavy. They are heavy compared to the baryons, that is protons and neutrons, and they carry charge also. W and Z. W particles carry charges. They are negatively and positively charged, whereas Z bosons are neutral in nature. And this a weak part, the W and Z bosons are responsible for weak interaction. This strong interaction gluons and weak interaction W and Z bosons. There is a major difference. There is a similarity also. That is, these two sets of particles, they act only inside the nucleus, but they are responsible for the mostly they are for gluons are responsible for the formation of nucleus, whereas these particles W and Z particles are responsible for the decay of the nucleus, for beta decay, and radioactive decays accompany it's possible only because of weak interaction and their respective particles. And example for weak interaction or beta decay, electron capture, and formation of energy, stellar energy inside the stars and sun. This is possible only of weak interaction. In weak, that is inside the stars, two protons interact with each other through weak interaction only, and it produces deuterium, and two deuterium nucleus combine together to form helium nucleus. This is all possible because of weak interaction only, and due to this also a large amount of energy is released, stellar energy is released, and this is possible only through weak interaction. Now, coming to the fourth interaction, even though there are four types of interactions, gravitational, weak, electromagnetic, and strong interactions, this gravitational interaction is not included in the quantum model. Graviton is a particle that is, graviton is a boson, and this particle is not included in the quantum standard model, quantum mechanical model. It is a purely classical theory. Gravity is purely a classical theory, and it is impossible to incorporate this classical theory, which is general relativity, which is explained by Albert Einstein successfully. Even though it is a successful theory, but it is a classical theory, and hence it is not possible to incorporate this classical model into the quantum world. And second, at microscopic level, that is inside the nucleus, the gravity is so weak that it plays no significant role inside the nucleus, and finally it is impossible to construct particle accelerators, high energy particle accelerators, to detect gravitons in the lab. And next is finally the Higgs boson. The Higgs boson is a God particle later finally discovered, and this particle special. Why it is so special? It gives masses to all the particles. It interacts with all the fermions except neutrino. Neutrino cannot interact with the Higgs boson because Higgs boson, that is a condition. For any particle to interact, Higgs boson interact with particles only with particles which have both right-handed and left-handed helicity. And in our standard model, there are 12 fermions, out of which 11 fermions have both left-handed and right-handed helicity, whereas this neutrino has only left-handed helicity, and hence Higgs boson cannot interact with neutrino. But there is a Japan observatory found that there is a negligible mass for this neutrino, but the explanation was not. Various theories come forward to explain the negligible mass of neutrino, but it is not due to, scientists believe that it is not due to Higgs boson, because neutrino has only one helicity, that is the left-handed helicity. And so finally we can say that the Higgs boson gives masses to all the particles in the universe. Particles in the universe have masses, and hence we exist, and the entire universe exists only because of Higgs boson. And today scientists seek to unify all the forces, and they are at work to find a single force, and all the forces in nature might be the manifestations of the single unified force that might lead to the grand unification theory. Thank you.